Okay, then close your notebook and textbooks. This is for homework. You cannot come to the class and study now. Done. Okay, so once you got your notebook, keep your textbooks closed. And give a simple ones, let us see how can be able. Ready to write test on the top. Never mind, don't run the atomic mass. I give you only the ions. Come on, ready. Right there on the top, test. Okay, write the formula form. My question is, give the formula form. Give the formula form. First, I'll give you the words, and then you will write on the formula. Is that okay? And no talking now when the test is going on. I don't want any word. First one, calcium oxide.
Oxide means oxygen.
You should know that. It's the test. I'm not going to help you know. Calcium oxide. Second one, magnesium chloride. You come first. You're so late. What happened? Huh? 4:15 is your class. Come first. You have started the test. Come on, quickly. Third one. No making noise. No making noise. Aluminium nitrate. Aluminium nitrate. Okay. Next. Potassium carbonate. Yeah, right. I think. Write the test. Potassium carbonate.
Calcium oxide.
Wait. Write on the fourth one now. Fourth one is not. Let me the fourth one.
Potassium carbonate.
Right, potassium. And one more I'll give you. Write on all of you write on. I'll give you confidence. Okay. Sodium nitrate. Write down the words and then you think about the problem. Sodium nitrate. Next one, zinc hydroxide. Zinc hydroxide. Okay, next one. What is it? Seventh one. Aluminium oxide. Okay, the last one. Hydrochloric acid. Hydrochloric acid.
Last one.
Hydrochloric acid. Write down the formula completely. And she completed the first one, calcium oxide. Then the second one, which is magnesium chloride. What's the third one? Aluminium nitrate. 5 minutes, not more than 5 minutes. We are not wasting time now. Quickly. Right next to the form. Write it down next to the formula. The word itself and other formula. Write it next to it so you can Maybe if you have finished, if you are following it, well, you should have finished. Not done. So, no, nobody is prepared for the test. You can make it. If you are prepared for the test, it will not take more than 5 minutes to do this. Have you learned? Sir, have you learned? Okay, see, formula you're writing only the ions, you're writing only calcium. What about the oxide part of it? Full formula you should write calcium oxide and then tell me what is the formula.
Aluminum.
No, looking that. No. No, children, if you will, I'm not done. I'm very, very sorry, but you have not revised. No. Very bad. I'm totally disappointed. I told you this chapter is over and it is a very important one. Look at the formulas, so forget about it. Now you make it as a homework. Cut out the text on the top, cut it out and write homework. And do it properly and come. Learn how to do it. That is homework. Now I want everybody to go home, check it out and write. What is the point? I will give you the answers, then again you will write down everything. When will you learn? Come on, I'm going to continue with the chapter. Atoms and molecules. Last time we done. Sorry, structure of atom. Okay. So we have already completed the position of what? Structure we have already seen. What does it consist of? It consists of a nucleus, and you also have got various electrons which are present in different orbits. So what does this nucleus consist of? This nucleus is made up of two particles. What are the two particles that we were telling? There are protons and neutrons. So protons are present which is positive, neutrons are also present which is negative. Neutrons are
Protons are positive and neutrons are
not negative, which is neutral. That means it does not have any charge. So that is why we put a zero. Okay, so now we are going to show that these electrons are the ones which are present in outermost orbit. Okay.
Ma'am, actually there was a lot of traffic and like the signal here. 15 minutes. Yeah, so there was.
This is the test. Yes. I told you that there was a test, right? Today? You learn? Not learn. Again, when you do badly in the test, when we have an open day, your parents will ask, why the children are not doing? What do we have an answer? Because the children are not studying, as simple as that. No? Afterwards, you take it down and you learn it up. You have converted it into your homework. Kashi, learn it now. Next time I'm going to have a test again. So, okay, so what are these? These are electrons and then negatively charged. So, how are we going to indicate? Check the board. Okay, so it is negatively charged. Okay, that means to say the number of positive charges and the number of negative charges, that is electrons, will be the same. The number of, I'm talking about number. Okay, therefore, will an atom have any charge? Will an atom have proton and electron charge? It will not have any charge because if there are 10 protons, there are 10 electrons, then obviously it will cancel out. So it will not have any charge. Did you understand all this? Clear till now? Okay. Now I'm going to tell you today regarding the distribution of electrons. Okay. So we said that these lines that I have drawn, these are what are called as shells, or they are also called as orbit. You remember this one? Look at the diagram that I've written in front. Have you written it? Is it written as shell or it is also called as orbit?
Orbit shell.
Yes, you have written. So these are like our highways. So all the traffic has to go in the highway. Okay. So similarly, these electrons cannot be present anywhere. It has to be present in certain energy shells. Okay. That means these are tracks where the electrons are going to be present. Okay. Now, Agmay, now suppose there are 10 electrons. Okay. Will all the 10 electrons come in the first orbit or in the second orbit? So there is a particular pattern that it follows. And now we are going to talk about the orbit. So first orbit is always starting. Look at the board. Everyone please look at the board. Okay. This is the first orbit. And so this is the second orbit, the third orbit, and the fourth orbit. Did you notice that the numbering is always starting from inside? So which is the first orbit? The first orbit is the one which is the innermost orbit. Okay. So we are starting from 1, 2, 3, 4, and so on and so forth. It's also called as KLM. Sometimes you'll see K, L, M, and N. Okay. So the alphabets that we have used is right from the innermost shell. That means the first shell itself. Is that very clear? Now, how are these electrons distributed? In the first shell, how many electrons are going to be there? In the first shell, okay, the number of shell, there will be only 2 electrons. In the second shell, you will have 8 electrons. Okay. In the third shell, obviously the number of electrons will be more. Now, what actually decides this? So there's a very beautiful and a very simple formula that we need to follow, and that is what is known as the Mohs formula. Okay. So here we are talking about a formula. Write down this. All of you write the formula. We are writing it as 2n squared.
Hormones.
Don't look at that. Don't look at the textbook like that. You're getting confused. You're turning the pages, not concentrating. Write down the formula. Okay, this is 2n squared.
Oh, what's
Okay, so when n is equal to the number of the shell, okay, so we are going to see in a very simple way. I'm drawing a chart for you. This is the number of the shell. So we are at the first orbit, second, third, fourth, etc. And we are going to use the same formula to find out the number of electrons. Okay. So number of electrons. Do you understand? We are going to use this formula. Remember this formula 2n squared. So for the first one it is 2. N is equal to 1 because it is the first shell. It is 1 square. How much will it be?
1,
1 square is 1. 1 into 2.
2.
How many electrons will be present in the first shell? There will be only 2 electrons. Even if there is a third electron coming, it will not come into the first shell. So maximum capacity is only going to be 2. So it is going to be 2 electrons. Is that okay? Did you understand? Now let us look at the second one. So it is 2 times, n is what here? What is the number here?
Square.
It is 2 square. How much is that now?
8.
Got it?
24.
2 2s are, that becomes 4, 4 2s are is 8. Okay. So there are 8 electrons which can be fitted in the second shell. Try for the third one. It is 2 times, n is 3 here. So I can put it as 3 square. How much is 3 square?
9.
Into 2? 18. So maximum number of electrons which can be fitted is 18. And we followed this concept is easy. Okay. So even though there are number of electrons in a particular orbit, all those electrons will not come into one orbit, but it has to be distributed in a particular pattern. Okay. So this itself is called as electron configuration. What is it called? Copy down this table. Or if you take down the table. Write down the formula to n square and do it on your own. No, come on. Just have to substitute that number n and then you get different numbers. What is the first shell called? First shell is also known as which alphabet?
K.
K. So K, L, M, and N. Write it in your notebook. K, L, M, N. Okay, so K shell is also the first one. K, L, M, N. And the first orbit is always from the nucleus. From the nucleus, from the nucleus.
We have to do fourth one also.
No, 20. How much will that be?
4.
4 squares.
32.
1 we have to write half.
32 is not 64.
No, like that. So 64 is
Got it? Okay. Now, what is electronic configuration? See, look at this word. Configuration. That means we are talking about the arrangement. So E and C. See, I'm writing it as EC. So every time when I put EC, you should remember that we are going to be talking about electronic configuration. So what is electronic configuration? It is nothing but the, come on, take it down. It is the distribution. It is the distribution of electrons. What is electronic configuration? We are writing it down. Take it down fast. Electronic configuration refers to the distribution of electrons. Distribution of electrons in various orbits. In various orbits. You can write orbits, you can also write it down as shells.
Various orbit.
Orbit.
below.
Orbit. What are shells? Shells are called as orbit. Did you get it? Okay. Now, we have here Bohr's model. I will talk about the scientists a little later on.
41.
Did you all get it?
41.
So that's it. Yeah, you can look. Okay, see there. Okay, see this. So there were various models put forward by different scientists. I will talk about all these people a little later. Right? Diamond structure, Thompson, Rutherford, I will talk about it a little later. I've come up with Bohr's model. What does it say? In order to overcome different type of operations. So he put forward a certain theory. Right? Turning your pages, look at that first point. And only special orbits, did you get those points? Only special orbits known as discrete orbits of electrons are allowed. So underline the word orbit here. This side.
Like
Second point, while revolving in discrete orbits, the electrons do not radiate energy. As long as these electrons are present in those orbits, they are not giving out energy. How can you realize that? Now, if you look at the diagram there, where's the nucleus? N is equal to 1, N is equal to 2. What is that number? N, what does it indicate? N.
PS.
What is N? It is the number. It is indicating the number. The first one, second
Number of
one.
cells.
It is the number. There. And what does it place? The innermost is the K shell. Okay? There. These orbits or shells are represented by K and M, or it can also be represented by numbers. Did you see this?
1, 2,
Okay, did you understand? Okay. Now, come to this 4.3. Look at 4.3. How are electrons distributed in different shells or orbits? Do you have the textbook with you?
The distribution of electrons into different orbits of an atom was suggested by Bohr and Berry. The following rules are followed for writing the number of electrons and different energy levels of shell. Levels of shell. First, the maximum number of electrons present in the shell is given by the formula to explain it.
Put a tick mark here or underline that. Okay. What is the formula which is used? We have already spoken about the formula which is equal to 2n square. What is this number n? What is this n? It is the number of the shell. Of the orbit, yes.
Where n is the orbit number of energy level index 1, 2, 3, hence the maximum numbers of electrons in different shells are as follows. First orbit of K shell will be
You have seen this is what I have put up in the form of a table. Okay, so first shell will have 2, second will have A, third, and so on and so forth.
Fourth is 32.
Actually, no, when you do it, it's not. Okay.
The maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given shell unless the inner shell are filled. That is, the shell are filled in a stepwise manner.
Okay. Now let's see what is meant by a stepwise manner. Okay. I'm going to give you one example. Is everyone with me? Okay, so let us see this, let us say, is the nucleus, right? The first orbit and the second orbit. Now I'm saying there are 5 electrons. Kaushik, where do you think first orbit में कितना रहेगा?
Not first orbit will have 2.
We have
2.
2. That's all. You cannot have more than 2. Even though there are 5, you cannot have more than 2. So you will have 1 and 2. So 2 are over. How many more are remaining? 3. So those 3 will come in the second orbit. Simple, will you understand? Okay. All the 5 of them will not go to the first orbit, but it is a gradual way by which this will be filled up. Okay. All the 5 of them will they come into the third orbit?
Yes.
No.
No.
There should be a
Unless the first orbit is filled up, unless the second orbit is completely filled up, the remaining only will come into the third orbit. Okay, can we have something like this? Let's say this is the nucleus. I've got the first orbit, the second orbit, and I've got 5 electrons. All the 5 electrons will come like this.
No. Yes.
Yes?
If the first orbit is not filled, can't
Is this correct or not? Is this diagram correct or not?
No.
No, it's not correct. Why? Because the first orbit should have 2 electrons. Did you understand? So the first 2 electrons must go into the first orbit, only then the second orbit will fill up. So what is the way it is filling up? It is filling up in a stepwise manner. Have you followed? Suppose you have steps like this. Can you directly go to the 5th floor? No. You have to come to the first floor, then you have to come to the second floor, and then only have to sleep. I'm not talking about a lift or anything. Suppose there is some kind of a arrangement. But unless you jump, we are not talking about any something. So we are talking about a stepwise arrangement. Did you get it? Now another thing that I want you to write down is what is called as atomic number. Did I tell you about atomic number? Have you learned about atomic number in the 8th standard? Remember something about atomic number? What is atomic number? Come on, tell me. Forgot. What is atomic number? It deals with the number of protons, as simple as that. Atomic number refers to the number of protons. If it is equal to the number of protons, it's also equal to the number of electrons. Suppose there are 10 protons, there should be number of 10 electrons, isn't it? So the atomic number refers to the number of protons. Why are we talking only about the protons? Why are we not talking about the electrons which are here? Because electrons sometimes in a chemical reaction, they can shift from one atom to another. So we usually don't take the number of electrons. We consider the number of protons, and where are the protons present? Position of the proton inside the nucleus. Okay. Suppose I say the protons There are 5 protons here. What will be the atomic number? 5. 5. Atomic number is number of protons. If the number of protons is 5, obviously atomic number is 5. If it is 50, what is the atomic number? It is 50. Did you understand? So atomic number is usually given by this alphabet. What is the last alphabet?
Zero.
What is this alphabet? Okay, atomic number is given by the alphabet, which is it. Suppose you have something like this. Suppose I'm just talking about an element. Right? I'm talking about an element, sodium. And I write 11 there. What does it tell us?
11 atoms of molecules.
Not atoms. We're not talking about atoms. Number, atomic number
The
is
number
what?
of atomic protons. Number of
Protons.
protons present in sodium.
In that. Did you understand? Suppose I write 11 here, which shows that the atomic number is 11. 11 also indicates the number of protons. It also indicates the number of electrons. Is that clear? Now, let's try to do this. Okay? Come on now. All of you write down. Come on. Atomic number. What is atomic number? Atomic number refers to the number of protons refers to the number of protons. Does it mean?
It's written.
Correct. Refers to the number of protons present inside the nucleus. In bracket, I want you to remember what you have to remember. Protons is equal to the number of electrons. In bracket, write down. The number of protons is equal to the number of electrons. Electrons. That. Okay. Is the atom charged? Suppose it has got 11 electrons. Will it be charged? Right?
No.
No.
Right?
Because the number of electrons and protons are balanced.
There are 11 protons, there are 11 electrons. Obviously, the charge is getting cancelled.
So therefore, no nucleus is balanced. Like every nucleus is balanced.
Balanced in the sense atom will be neutral. An atom, this is an atom. This atom of what? Of which element I've given you an example about sodium. That is going to be neutral. Why is it going to be neutral? Because the number of electrons and protons are the same. Okay, did you understand? Someone take down this diagram. Take down this empty diagram. We are going to fill up. How many electrons and how many protons are present in this diagram? I want you to fill it out. Write down question. Draw the number of electrons and protons in this diagram.
Any number.
I've given you for this number only you have to give.
Sodium.
It cannot be any number. I've given you for sodium. What does the 11 tell us? What is 11?
Electrons.
What does this 11 stand for?
Atomic number.
Okay. So I write Z, which is atomic number, is equal to 11. Atomic number is equal to what?
Proton.
Number of protons. Number of protons is how much? 11. If proton is 11, how many electrons will be there?
11.
So number of electrons is also equal to 11. Now I have all the information. Can I fill up the protons?
Yes.
Where are the protons?
Yes.
Inside the nucleus. So protons is equal to 11. Okay? Now Electrons,
And we need one more of that shell.
that is why I did not draw. Good. Good that you have recognized. Now electrons are 11. I want to find out what is the electronic configuration. What does EC tell us? Electronic configuration. First shell में कितना है? Always 2. So I am putting 2. Second shell में कितना आएगा? 8 आएगा. Correct? So 2 plus 8 is how much? 10. बाकी कितना है? 1. So this is how you will write now. So 2 in the first shell. Second shell, how many you will write? 8. So you write 1, 2, 3, 4, 5, 6, 7, 8. There should be another shell, no? How many shells? One more shell is there. So there will be one more shell you will draw. I'm showing 1 electron. So how many orbits are present in sodium? There are 3 orbits present in sodium. Got it? Don't look at the board and draw. You should know it now. What did you draw this? Did you write down this information? Michelle, first you write down this information, then you understand. Got it? What else is there inside the nucleus?
Neutrons.
Yes. Right now, I have not drawn the number of neutrons. A little later, I'll tell you what are the neutrons. Okay? Do neutrons have any charge? No, they don't have. For convenience sake, I'm putting it as 12. You just write down number of neutrons. Number of neutrons is 12 here. Okay. It need not be the same. Sometimes the numbers can be slightly different.
But we need to draw like structure of the
Neutrons is always sitting inside the nucleus. So there's no drawing, just indicate the number.
how is it drawn?
Sometimes atoms are not slightly different. Neutrons are neutral, no? So it is immaterial whether it is more or less equal. And for the lower atoms, for the number, it is more or less similar to the number of protons. Got it? You want to try one more?
Yes.
You have understood now how it has to be done? Come on, let's take another one. Suppose I'm giving you. Okay. Next one. Draw the structure. Come on, take down this question. Draw the atomic structure of carbon. I'll put a 6. What does it tell us? Okay. The number 6 is very important because that will give you a lot of information. What is it? Atomic number. What is the atomic number? Abhishek, what is the atomic number?
6.
What it? Okay. Atomic number is equal to what? Number of protons.
6.
Ahmed, tell me. How many protons?
6.
86. Correct. How many electrons will be there?
6.
6. Okay. And I am also telling you that the number of neutrons will be also 6. Okay. Now, I want you to also write down electronic configuration. Easy.
2,4.
Yes. 2 electrons in the first orbit and remaining 4 will come in the second orbit. Come on, you draw it from. What was the mistake you have done? Tell me. What was it? Okay, did you understand? Okay. I don't know full information. I put up so many things in the atomic number, number of protons, right? And all that information. Finished? Right. Why two? Inside the nucleus, how many will be have? 6. What is that 6? What is inside the nucleus? It's number of protons. So you should write P is equal to 6. Will you write? And how many N is there? How many neutrons? Will you indicate the number of neutrons? Proton also should show. You should also show neutron. Okay. All of you check whether you have run this properly. Inside the protons, inside the nucleus, you'll have protons and neutrons. Protons are plus, neutrons are 0. So this is 6, this is also 6. Okay? Then you are going to draw the first orbit, which will have 2, and then you will have the next orbit, which is 4. Is that okay? Did you understand? Okay. One last one I'm going to give you. See whether you're getting it correctly or not. Ready? What is Ne? What is Ne? Na is sodium. Ne?
Nitrate oxide.
See, nitride and nitrate is ion. You're talking about
Nitrate
ion.
oxide.
This is what Ne is an atom. It is neon. What is it? It is neon. So put on this.
Inside.
You're not done, no? All of the things. Listen.
Same. And 10.
I want you to draw this. I know the information. I start see what you're doing. Sorry. I'm going to give you that sheet. Okay. Okay.
I'm very diamond.
Same.
Did you edit?
And Z is 10.
How many protons do we have?
10.
How many electrons?
10.
And what
Neutrons
is
10.
it? What is the distribution?
1.8.
So this is a very special type of a configuration. Okay. One of the points when we were reading, did you notice?
It doesn't.
It does not exceed 8 electrons. The outermost orbit, if it has got 8 electrons in the outermost orbit, it is very, very stable. Okay? Okay? So this is what is known as an octet. Octet means what? Like an octopus. It means 8. Okay, so therefore it has got 8 or it has got an octet configuration. Can you understand? So if you look at your textbooks, see this. See this?
Yes.
Do you understand now? But of course, they have not indicated the nucleus, they just put a dot for the nucleus. But in the diagrams here, we have drawn the nucleus and also indicated the protons and the neutrons. Okay, so that is the Ampi diagram. So read the first one. What is H? Right from here. H is what? Hydrogen. He?
Helium.
Helium. Li. What is Li?
Lithium.
Lithium. Next.
Helium.
Beryllium. Beryllium.
B.
Boron.
Next is boron. Okay.
C. Carbonate.
Carbon.
Carbon.
Okay, C is carbon. Next time I will give you a list at least up to 20. I'll put it up on the board and you can take it out. Argon is there, yes. 18 is there, argon.
And
And then
nitrogen.
nitrogen and last 19 and 20.
Nitrogen.
Nitrous chlorine, Denise.
And neon.
What is this now? What did I put up here?
Sodium.
Neon.
Neon.
See, count and see how many
I'm
electrons.
saying.
Same. 1, 2, 3.
Got it now. So starting from here, all of you look here. Hydrogen put a one with pencil,
Yeah. What?
That is atomic number 1. Helium, that is atomic number 2. Okay, lithium is 3. Then helium. And 1, 4, 5, 6, 7, 8, 9, 10.
Then.
What is sodium? What number is it?
11.
That's 11. Okay, right, continue. 11, etc.
And
Abhi kya na?
Well, 13, 14. We can remember it like this.
Very easy. I tell you a simple trick.
Ma'am, only 18 are there. Okay.
Okay.
So 18 is.
What is the name?
And sodium.
Mg,
Magnesium.
magnesium. An,
Aluminium.
Si,
Silicon.
silica.
Silica.
P,
Phosphorus.
Mes,
Silver. Sulfur.
sulfur. C1 is Ag. Okay. S is sulfur. Cl,
Chlorine.
last one,
Argon.
argon. And you will remember it. 19 will be potassium, 20 is calcium. 19 and 20. So we are complete with this engineer we have understood. Okay. So the structure, atomic structure of the first 18 elements is what is shown here. Understood? Yes.
Yes.
Yeah. Come to the next page. Come to the next page. Today we have done atomic number also. Put a tick mark there.
Atomic number. Mass number.
You
Mass
will
number.
not
Mass number. Shh.
atomic number. I asked you to put a tick mark, not mass number. Now read atomic number.
we know that protons are present in the nucleus of an atom. It is the number of protons of an atom which determines its atomic number.
Underline the statement.
It is the
What determines the atomic number? It is the number of.
number of protons of an atom.
Underline. Yeah, continue.
All atoms of an element have the same atomic number Z. In fact, elements are defined by the number of protons they possess. For hydrogen, Z that is equals to 1. Because in hydrogen atom, only one proton is present in the nucleus. Similarly, for carbon, Z that is equals to 6. Therefore, the atomic number is defined as the total number of protons present in the nucleus of an atom.
Are you okay?
Atoms and molecules. Where there are isotopes and isobars for us.
Isotopes is there, isobars.
No,
are
in
there.
atoms and
Previous
molecules.
chapter.
Previous chapter.
What?
What
Where there are isotopes and isobars.
Ma'am, in CBSE we got
SCPS, isotopes and isobars in atoms and molecules chapter.
Because here in this one,
Ah,
here we
Ma'am, but we didn't do it.
do it.
I think in the 8th standard you had a small introduction to isotopes and isobars.
Isobars,
First isotopes will be
No,
taught
no,
and
no,
then
no,
only
no,
you will
no.
understand the isotopes.
No, not the isotopes. Isobar.
So what, it was there in the test paper?
SCPS one.
Ma'am, we did that.
We did attempt it.
And then we were asked to balance something like.
I'll tell you what are isotopes. Once you understand it clearly, then it becomes very easy. Okay? So, what have we seen now? We have seen that if at all you're having, let us say for neon, and we know that the atomic number, what is the atomic number for neon?
N.
Where did we write it? Did we write above or below?
Below.
Atomic
So this is where you will write it as 10. So any number which is written below is
Atomic
Z,
number.
which is Z.
Z.
Okay, so nobody is going to tell you that this number is going to be atomic number. Now you should know that the subscript, what is it called as? It is the subscript, that means below whatever has been written, that is your atomic number. Now I'm going to introduce maybe atomic mass number and take it up next.
Atomic mass number is the same thing here.
Atomic mass number is different and atomic number is different.
It is related to the same thing, right?
No. Okay,
Mass
Let me tell you.
number.
yes. Suppose for chlorine, I'm writing Cl. What is Cl?
Chlorine. An atom of chlorine.
Well, okay. And I write 17 here. What does it tell
Atomic
us?
number of seconds.
Mass.
Chlorine is 17.
Z is equal to 17.
17.
P is equal to
17. N is equal to
E is equal
17.
to
E is
17.
17.
N we do not know. We do not know N. N may not be, sometimes it can be 17, it can be 18, etc. In this particular case, N number of neutrons is 18. Okay. So when we have the sum of proton and neutron, this is what is known as your mass number. Did you see that? It is the sum of the number of protons and the number of neutrons. Okay, and mass number, how do we indicate it? We indicate it by this alphabet A. Yeah, is that okay? Now in this case, what will be the mass number here? 18 plus 17, how much is it?
34. 36. 36.
8 plus 7 is how much?
15.
35.
35. Okay, so where will you write 35? 35 is written on the top like that. Got it? So any number which is written on the top will refer to A. Any number which is written on the bottom will be Z. It's very easy to remember A to Z. Understood now? What is A? What is A? It is
Mass
mass
number.
number. It is the atomic mass number.
B
And what is Z?
Atomic number.
atomic number.
Okay. So in this particular case, it is 35. So Z is 17 and A is 35. Is that okay? If A is given, will you be able to find out the number of neutrons?
No.
Yes. 35 and 18.
Neutron.
Is that clear? Come on, write down a few things before I wrap it up. Atomic mass number. Come on. Atomic mass number. Wait. Alphabet is A. Atomic mass number, which is alphabet equal to A, refers to the sum of what? Sum of number of yes, sum of the number of protons and the number of neutrons.
The
Sum is addition.
sum
Where is it to be written?
On the top left side.
Superscript. What is it called? Superscript is super is above. Sub is below. You'll understand a submarine. क्या है? Submarine. What is a submarine? mean?
Underwater.
Below the
Underwater.
water.
Sub is what? Below.
Summer.
Okay, तो नीचे आएगा. Super कहाँ है ना? Is on the top.
An example can be written.
Yes. Now you take down this example. Chlorine. Write down chlorine. Not sodium. Cl is what? Chlorine. And on the number on the top, what will you write? 35.
Now, on what basis you took the number of neutrons?
And that is given to us. That is known to us.
So in the exams, we will.
Neutrons, there's no need for you to learn the neutrons. But I'll tell you a method how you can find out the number of neutrons.
Done.
Complete this whole thing.
No.
Subscript we have to write.
What is superscript, what is subscript, all that you should know. Just leave the textbook down. Mass number.
1 minute. And 1 minute. Okay.
All of you please do your homework. The previous chapter you are not yet thorough. Okay? Don't come to the class and say, no, I have forgotten. Learn and come. Mass number. You got it. Read from it.
Mass.
After studying the properties of the subatomic particles of an atom, we can conclude that mass of an atom is practically due to protons and neutrons alone.
Stop. Underline that statement. It is due to the protons and neutrons alone. Okay, please stop here. Next time I will give you some more examples. Also teach about various other concepts and also talk about the various assignments. What is the homework? What is the homework?
Test.
And learn the ions formulas thoroughly. Thank you. You got the more?
Master,
Bring it in.
Here